In this video, we are going to look at how to use integrated red law equations to do calculations. Hey, I'm Teacher Tang. If you like my video, do remember to click on the subscribe button below so that you won't miss any notification as I update my channel.
To solve calculations questions related to integrated red law equations, basically there are three steps to follow through. Step number one is to write out the information given by the questions. Step number two is to choose appropriate formula based on the order of the reactions given. Step number three, you just need to substitute the information given in step number one into the formula in step number two and calculate the final answer. Now we move on to look at example one. How to solve this question? Again, to solve this question, we need to follow through the three steps. Step number one is to write out the information given. What are the information given in this question? So, first information is the rate constant, 9.2 times 10 to the power of negative 3 per second. And the second information given is 56% of the sample decomposed. So, means that 44% of the sample cyclobutane reactant C4H8 remain in the reaction. So, these are the information given in the question. Step number two is to choose an appropriate formula to do the calculations. For this question, it is mentioned that the reaction is first order, and that we want to find how long it takes for the reactant cyclobutane C4H8 to decompose, and how long here refer to the time. In reactions kinetic, there is only integrated red law equations involve the time term. Therefore, the most appropriate formula that should be used to do calculations is the integrated red law equation for first order reaction, and the formula is ln concentrations of cyclobutane C4H8 equals to negative rate constant K multiplied with time plus ln initial concentrations of reactant cyclobutane C4H8. And the concentrations here is referring to the remaining concentration of cyclobutane C4H8. In step number three, we just need to substitute all the information given in step number one into the formula in the step number two to get the final answer. From step number two, we know that this is the formula that we need to use in order to calculate the time. From this formula, we need to have the initial concentrations of the reactant cyclobutane C4H8. But in this question, there is no initial concentrations given. Therefore, for this question, since no initial concentrations of reactants be given, we can assume that initial concentrations of the reactant cyclobutane C4H8 as 1 molar. And 56% is being decomposed, so means that only 44% of cyclobutane C4H8 remains in the reaction after the time t. And that 44% is equal to the 0.44 molar of cyclobutane C4H8 remain in the reaction after the time t. With that, we then can substitute into the formula to give us the time 89.24 seconds. Now we move on to look at example 2. So example 2 consists of two questions, so I will do these questions one by one. For question number 2a, we want to calculate the value of rate constant in per mole liter per second. For this question, again, we need to go through the three steps in order to get the final answer. So step number one, we need to write out all the information given in the question. So what are the information given in the question? So the first information is the initial concentrations of the reactant A, which is equal to 0.234 molar, and also the time of reaction, which is 1.16 minute. We need to convert it to second because the unit of the rate constant given is per second. Therefore, the time 1.16 minute need to multiply by 60 seconds per minute to convert the time to second, which is equal to 69.6 seconds. And also been given that after 1.16 minute, the reactant is being reduced to 51.2%. So this 51.2% is the remaining percent of the reactants A in the reaction. And that 51.2%, we need to convert it to concentration. How do we do the conversions to concentration? So what we need to do is, we need to use the 51.2% multiply by the initial concentration to give us 0.1198 molar as the remaining concentration of A after 1.1 minutes of reaction. Number 2 is to choose an appropriate formula to do the calculation. In this question, it involves time. So means that we must use the integrated rate law equation. But which order integrated rate law equations must be used? In this question, although we are not being given the order of the reaction explicitly, but we are being given the unit for the rate constant, which is per mole liter per second. And this is equivalent to per molar per second. And this is equivalent to the unit for the rate constant for the second order reaction. Therefore, the most appropriate formula should be used is the integrated rate law equation for second order reaction, which is equal to 1 over remaining concentrations of reagent A equal to the rate constant K multiplied by time plus 1 over initial concentrations of reagent A. Step number 3 is to substitute all the information given in step number 1 into the formula in step number 2 to get the final answer. So for this, the rate constant that we get is 0.05852 per mole liter per second. In example 2b, we want to calculate the remaining concentration after the time 102 seconds. For this, again, we need to follow through the 3 steps. Step number 1 is to write out all the information given in the question. So what are the information given in the question? First is the initial concentrations of reagent A, which is equal to 0.234 molar. And second, the time of reaction, 102 seconds. And the rate constant is the one that we calculated in part A, 0.05852 per mole liter per second. Step number 2 is to choose an appropriate formula to do the calculation. For this question, again, it involves time. So we must use the integrated rate law equation. Which order? From the part A, we know that this reaction is second order. Therefore, we should use the second order integrated rate law equation to do the calculations. And the reagent here is A, so we can use A as the reagent in the formula. Step number 3, we substitute all the information given in step number 1 into the formula in step number 2 to get the final answer. So for this, we get the remaining concentrations of reagents A after 102 seconds of reaction as 0.09763 molar.
Example 3 is slightly different from example 2 and example 1. So these questions actually consist of 2 parts. And in the first part of the question, we are being given the initial concentrations of the reagent X and given the time and also the remaining concentrations of the reagent X. So means that in the first part of the question involve integrated rate law equation because involve time. And we are actually looking for the rate constant for the first part of the question. So what we need to do in the first part of the question basically is to follow through the 3 steps and look for the rate constant. And in the second part of the question, then we are looking for the time. Given 50% of the reagents decompose. So this is the second part of the question. So again, in the second part of the question, we also need to follow through the 3 steps in order to find the time taken for the substance or reagent X to decompose by 15%. So now we shall look at how to find the rate constant in the first part of the question. So again, step number 1 is to write out all the information given to us in the first part of the question. So in the first part of the question, we are being given the initial concentrations of reagent X, 2.5 times 10 to the power of -2 molar, time 8 days, and also the remaining concentration of reagent X, 1.8 times 10 to the power of -2 molar. Step number 2 is to choose an appropriate formula. So in these questions, it involves time 8 days and given 0 order in X. Therefore, the most appropriate formula is the integrated rate law equations for 0 order. Step number 3 is to substitute the information given in step number 1 into the formula in step number 2 to calculate the final answer. So with this, we get the rate constant K equals to 8.75 times 10 to the power of -4 per days. For second part of the questions, to solve it, again we need to follow through the 3 steps. So step number 1 is to write out all the informations that are being given to us. So we are being given the initial concentrations of reagent X, which is equal to 2.5 times 10 to the power of negative 2 molar. And also, from the first part, we already calculated the Rate constant, which is equal to 8.75 times 10 to the power of negative 4 per days. And then given in the question, 15% of reagent X being decomposed. And that 15% is equal to 3.75 times 10 to the power of negative 3 molar. And in the calculations, we need the remaining concentrations. So to calculate the remaining concentration, we just need to use the initial concentration, which is 2.5 times 10 to the power of negative 2 molar, minus the 3.75 times 10 to the power of negative 3 molar, which is being decomposed to give us the remaining concentrations of reagent X after some times, which is equal to 2.125 times 10 to the power of negative 5 molar. Then in step number 2, we need to choose appropriate formula to solve this question. So again, in the second part of the questions involve time, and questions given is 0 order in X. Therefore, the most appropriate formula is the integrated rate law equation for 0 order. Then in step number 3, we just need to substitute all the information that we have into the formula in step 2 to calculate the final answer. So that gives us the time taken for the concentrations of reagent X to decompose by 15% equal to 4.286 days.